It's recording started. Oh, yeah, it's started now. So here, second thing is how we are going to read the topo sheet. That is, this is degree minutes. The coordinate systems, the whole entire India, not only in India, entire the country. I mean, sorry, the entire world. It's divided into different grid patterns with the latitude and longitude. Ushnamsha and the Reiki. That we call it as a latitude and longitude. That's the coordinate systems. So the plane from Bangalore to Delhi, or from Bangalore to Dubai, Bangalore to America, or maybe in Delhi to America, how it is running through the latitude, longitude, known locations. Fix the target and just to travel it. That's how the things. The whole world is, controlled with the latitude, longitude. That is how the GPS is working. Wherever you go with your GPS, it follows you. It gives you your exact location, and it will give you the what you call the track of your the where you travel, where you walk around the your area of interest, or it may be in the city. Wherever you go, if you have the GPS, definitely it will give you the your latitude, longitude. That means exact your locations and also the your track. And the same thing is happening for they set up the system in the aeroplane. From Bangalore to Delhi. If you want to travel with the airplane, the pilot will fix the Delhi airport location. Yes, it will take you there. Exactly the direction, and that's called your 360-degree angle. Anywhere, which degree we have to fly it. That height is depends on the ACT, what is called air traffic controller. They will suggest them which height you have to go there, 33,000 feet or 20,000 feet or 25,000 feet, depends on the their air traffic the situation. But the thing is, it works with the GPS systems that contains the what you call your the coordinate systems. There are coordinate systems, or there are four types. One is degree, minutes, seconds. Degree, minutes, and seconds. Second one is decimal degrees. See here, this is a decimal degrees. Here 75, 30 degree. It's a decimal degrees. Another system, degree, minutes, and seconds also will be there. Latitude, longitude. In both the things, degree, minutes, seconds, that's a one format. Second format is decimal degrees. Third format is, that's called your UTM, Universal Transport Meter. That's in a UTM. We call it as a UTM coordinate. That is in the numbering. That's in meter actually, not in what you call degrees or minutes or seconds. It's in meter. Generally, for mineral exploration, for and also for mine survey, for even local any survey, we use for UTM coordinate systems, because that is easy to plot the what you call your data into your paper on your plan, because that is in the meter. So if you fix with the degree, minute, seconds, that's very difficult to convert and fix the things. Okay, generally we used to take the degree, minutes, seconds. These are the different what you call latitude, longitude, the systems. Latitude, longitude, this is the one systems, gridding systems. The whole world is controlled with the latitude, longitude. Say for example, this is Dharwad districts, and for these I would say it's Gadag, and it's almost, I would say it's near to this 75 degree 15 or 18 minutes, okay, and 15 degree 20, yeah, it's a 26 degrees. This is your location. This is a Gadag locations. I would say this is a Gadag location. This is how each and every corner of India and the world is surveyed it and that's a fixed it, right? Don't think that okay, this area is not surveyed, that area is not surveyed. It's completely surveyed. It's completely covered with the entire latitude longitude systems. Okay, this is a, the topo sheet is like this. Same thing is for satellite imageries. Same thing you can get it from the satellite imageries. This is not exactly the this one, but of course it's some type of satellite imageries. What I would suggest is that let me show you the, the coordinate systems here. Yeah. Okay, so here is the coordinate systems are like this, right? Yep. Now let's go back for with the okay. Let's go back with a what you call this topographical survey and yeah, where we live for the yesterday. It is today. Yes. That's the topography and the scales. Yeah, we were here in the maps of topo maps of India. So how the numberings are there and how to read the the topo sheets or any other maps. That's what I told you that the distance on the ground, sorry, distance on the map divided by distance on the ground. This is how it work for the things. Okay, right, and yeah, for here, right. So it's a 1:50,000 scale. So 1 centimeter on the ground, 1 centimeter in the map, and 500 meter on the ground. Okay, so this is a small. Maybe you have seen this. The contour maps. It is the not clear is. It's a contour maps. Yeah, it's here. It's clear. 16, 14, 12, 18, 2. These are the RL elevation. This we call it as an RL. Just I show this because it was not showing properly in the topo sheets. This is the contours. Okay, contour is nothing but an imaginary lines which connects the equal elevation of the areas. Say for example, here is completely this is a what you call this 16-meter RL from the mean sea level. Okay, what do you mean by mean sea level? Means with respect to the sea level, sea is the sea and land. Its boundary is called as zero. When it comes to the when you go enter into the what you call this sea, there will be a minus. So when you are landing, I mean towards coming towards the land, it is a plus. So this is with respect to the what you call this mean sea level. All the the RL, we call it as a reduced level. In survey terminology, we call it as a RL, but in general terminology, we used to call mean sea level, MSL. Okay, that's how the things. So here is the the small mound or maybe a small hill, and that's why showing the 16 here and 2 here. 2 means lowland and 16 is the highland. This is a small hill. That's how you can. It may be a small valley also. When this RL elevations, sorry, when this RL values, this RL values is supposed to be the reverse. See, if 2 meters here, this is a 4, this is a 6, this is a 8, this is a 12, 14. So in that case, this is a valley, and this is a valley when it's 2 meters here. When the 16 meters here, elevation is here, that may be the hill. So when you cut the hill, and you can show this profile. So like it goes like this. If it is a hill, like this. If it is a valley, it comes like this. This is a the cross section you need to prepare in the survey part. Okay, and yeah, this is another map. Yeah, there are 2 hills and 1 valley here, and you can see this. Yeah. See, this is a 1,000 meter, and this is a 1,200 meter something else. These two are hill, and this is a valley. So this is the easiest way of what you call identify the topography of that. Okay, this is the flat land, and this is a top hill, and this is a top hill, and slope is toward this side. You can see the arrows. Okay, this is how when the gets the line, the water will flow this direction. This is all about the the topography which you are going to study there. And yeah, this is a scale, and it's a meter, and this is in centimeter. 0 to 500 centimeter, that's called a 5 meter, 10 meter. This is how you are going to familiar with the meter or centimeter, how you are going to conversion of meter to centimeter. Okay, right. And yeah, this is centimeter, 2 centimeter or 3 centimeter, whatever things. This is how the conversions. So now let's go with the, yeah, this is what we discussed in the today morning. Okay, the respect to the scales. Okay, this is how we are going there. So now let's start with the what you call the error. What are the major errors which are going to happen, which you are going to encounter during your survey part? What are the errors? What are the errors which you are going to encounter in the survey? The first thing is maybe the human error, or it may be the by mistake, unknowingly, or it may be the systematic error. Okay, you are trying to avoid, but still it is happening. It's a system. An accidental error will happen, and instrumental error. Okay, see, these are the types of errors which will happen during the survey time, and these are all the different we have classified errors, types of errors. Why we are making the error? That's a human nature. It may happen, it may not be happen, but we can classify it. Okay, human error, mistake, systematic, accidental, and instrumental error. Okay, what do you mean by the mistakes? Mistakes, error, while conducting dumpy level survey, or an auto level, or by using your tape survey, or it may be a chain survey, or it may be your what you call a compass survey, or it may be if you are survey doing the survey with your total sessions, right? So there will be chances of getting the error, or it may be there are a lot of obstacles in the while in your survey areas, there will be a lot of error may happens. So this is how we are going to classify it. So mistakes are the errors due to the carelessness of the observer. Those who are conducting the survey, they have to be take care of a lot during the survey time. They may be due to the wrong readings, or maybe recording the observations. That is the mistakes. These errors are very large, and it can be easily detected by the field procedures. Okay, and generally the targeting objects, before taking the readings, you have to observe very neatly. Okay, and taking the multiple scale of readings and records. Generally, this type of errors, it may happen in this. Okay, recording loudly announcing in the reading areas that readers hears what he can record. That is a difficult part. He may say that 510 meters, and you may think that 500 4 meter or 5 meter, or it may be a 515. Instead of 515, you may listen 550 meters. 503, you may listen 513 meters. This is how the errors will happen by mistakes. Okay, taking the additional readings for checking, that is also type of mistakes can happen. And then next, systemic. These are which follows the well-defined patterns or classified systematic. It can be determined by mathematical expressions. Mathematical expression can be called as a systematic error. They can be regarded as a positive. Say, for example, If we make the results too great and as a negative, the results we call too small. Okay, for example, errors are used for the tape which is shorter than the actual as per the marking, and or using the steel tape at a temperature different calibrated meters. Okay, if the tape is too short and you want to measure the longer one, and you have to stress the things, I mean the tape, or else you can mark it and again you go back there, and the marking place is disturbed again, and you are going to continuing the survey with different place from where you marked that. That's also chances are there. These are the systematic error. Okay, and this type of error is called a cumulative errors, and each since each measurement adds to the error into the same sense. That means when you are going to survey, say for example one complete like in a polygon way, let's say for example in the couple of session back, I showed some of the field, the difficulties how the water, you know water pond, the what you call storage tank areas. So how we are going to survey with with the different elevations. That time the error will accumulate when you are going to survey for the water pipeline, high rise, rising water pipeline for the um, water supply for the community or maybe the town. If you made a small mistakes from the first point, and that error will accumulate for second point also, third point also, fourth point, fifth point, like that it will accumulate the error till the end of your survey, I mean end of the day survey. So by that time you need to you know get it done, rectify at the first day level only, first stage only. Otherwise you cannot you know um, correct the errors. So if there is 100 points for the particular area, if you take it, and the error is happened at the 10 point or 20 points, and the error you need to distribute for all the 100 points, that is a very difficult part. Instead of that you can do the survey immediately. That is the one. That is how I know the errors are cumulative, and it will accumulate each and every stations or each and every point. Okay, and accidental error, how the accidental error are happening. There are errors in a measurement which cannot be prevented even with a sufficient care. Say for example you are doing the total session survey, so for construction of what you call dam construction, or it may be for reservoir constructions. So you are taking care of lot with all the supportive the staff, but still there's some errors are happening. That's called a accidental error. These error may be positive or it may be negative. Okay, and it may be vary reading to readings. Okay, and reading with the survey instruments. Okay, it has its own eye limitations. Okay, right, and marking the end of the chain length, it's another common example for accidental river the error. And there are some thickness of the marking, and its exact position is contribute to the accidental error. Okay, and some errors it's called deterministic. They are probabilistic, hence they cannot be estimated using the standard functionals. So error may happen, accidental error. It may be positive or it may be a negative. Okay, so this is an accidental error. Even if you are taking the sufficient care, it may happen like this. But either it may be a oversight or it may be other side of your staff. When you are conducting the survey, it may be happen like this. Okay, and then what are the sources of errors? Okay, I need to incorporate one more error here. That's called an instrumental error. Say for example, I think I told you in the last class, there are the instrument, especially the sensitive one, very sophisticated, that's called a total session survey instrument. You need to keep that instruments in a shadowed place. That's the best way of get the the instrument lifelong, because it connects, it's having the battery, the chargeable batteries there inside, and it may give some error if it is overheated. It definitely will give some readings, but it may be the wrong readings due to the overheat of the instruments. If there is any, if you are doing the survey in, especially in the summer season, you need to take care of your instruments. It should not be overheated. Okay, it may give the false results to you, false readings, and just randomly you are saving the your data, survey data, into your soft systems. That means the inbuilt of the the total station instrument. So when you come back to the camp, and by the evening, if you are going to download it, just you are downloading that, you are not observing that. Then when you are going to do the interpretation plotting part, that time you are going to get the problem. So how come it is? That's because of overheat of the instruments, because it's a very sensitive, and it's a, you need to take care of that. Either you keep the umbrella for the instruments, or you can keep the instrument in the where there is a shadow, and where from there you can see all the your survey points easily. You can, otherwise you can set the instrument wherever you require, and you keep the umbrella for the particular instruments. That's the most important. Otherwise you will get an error. You may not know that you have accumulated a lot of error by the end of the day. These things are happening for all the things: human error, mistakes, systematic, accidental error, and even instrumental error also. Okay, these are all the things, are different types of the errors may going to happen there. Okay, and the third part, okay, and this accidental error. And what are the sources of errors? I told you that instrumental, natural error, and the careless. Okay, that's both the same. Right, that we discussed there. Instrumental error. Instrumental error, another problem is called it's used for linear measurement, may not be having the true length due to the manufacturing defects. Yeah, that's another type of instruments problem, is manufacturing defects. Instruments may not show the true horizontal and vertical angles due to manufacturing defects, or it may be adjustment of the instruments properly. Before starting up any survey, you need to set up the tripod perfectly, centering all the bubbles in all the corners. Okay, and make it proper in the north direction. Okay, then the limitations. Okay, there are some limitations on the scales which you use to contribute to the instrument error. One thing, you may not set the instrument properly. Second thing, manufacturing defects. There are two things in the instrumental error. A natural error will creep in because of natural phenomena like variation in the temperature, humidity, okay, and curvature of the earth, magnetic declinations. Okay, these are all, they are maybe properly accounted to arrive exact values. So this is how the natural errors. Okay, if there is an overheat, more temperature in the nature, instrument gets what you call heat, overheated, and it may give the wrong the values. And human limitations, high setup, those things. And when you are marking the chain or tape survey at the ends, that is also one possible of human limitations. Okay, that is the thing. And the carelessness that we did. And then most probable values for accidental error that we discussed there, right? So then these are all the things. And then yeah, next is a measurement of horizontal distance. How we are going to measure the distance? So far we discuss what are the units, what are the measurements, what are the classification of maps, principle of surveying, definition of surveying, different instruments, what are the instruments which we are going to use for the particular survey. Okay, and we discussed the topography map. Those topography maps, what are the information you can get it from the topo maps. Okay, who has surveyed that. Okay, and also the when it was surveyed. Okay, Okay, those things we discussed so far. Now let's go with the measurement of horizontal distance. Okay, how you are going to measure the horizontal distance? There are many methods. Okay, approximate methods of distance measurement. These methods are used for reconnaissance survey or to detect the major distance. Okay, and especially for the smooth roads. Okay, approximate methods of direct measurements are listed. So one is pacing, another one is a passometer, another one is a pedometer, another is a odometer, another is speedometer. There are the different methods are there to measure the horizontal distance, and even that another one called you can walk and you can measure the distance. That's called a pacing. Pacing is nothing but the surveyor walks along the line to be measured and count number of steps. In a village side, those people are doing like this. Okay, 10 steps means 10 meters. 10 steps means 10 meters. It's approximately maybe 1 or 2 inches varying, but it will give the nearest to the answer, not exact answer. But in survey, we need the exact answer. In a Bangalore, 10 feet is more, 5 feet is also more because there is a cost. So 1 square feet, if you are paying 8 to 10,000 in particular place, so definitely 1 feet is 1 inch, 1 inch or 2 inches is the most important in Bangalore cities. But when it comes to the mineral exploration, we were in the what you call in the forest area. Okay, 10-20 meters is not a problem for us. We can rectify it in the later stage because GPS itself is giving the 4 meter error. That means 4 meter error in the sense where you are standing from there, the 4 meter radius, it may be very variation 3 to 4 meter, 2 meter, depends on the the satellite signals, depends on the thick forest where you are standing there. That is how it counts. Okay, so here when you walk pacing, the first method is the pacing one, which is just like when you walk around all along the line and measure number of steps. That number of steps is equal to your, if your steps are 10 steps, that's a 10 meters. Yes, because I did the thing same survey, because when we used to go for mineral exploration in the bushes, we used to do the same survey. How much in it? 10 to 30 50 meters we can easily measure it. Maybe 1 or 2 feet is varying, that's not a problem for us. As I told you, when there is a value for the land, particular place, it will cost. Even 1 inch, 2 inch also cost. Okay, the distance is measured equal to the number of steps. Pacing is nothing but the surveyor or the man can walk all along the line and measure the number of steps. One step is that's equal to 1 meter. See here, number of man exits length 0.75 depends on the person to person. Okay, the 6 feet height man can one step maybe the 1.2 meters. The short fellow can walk maybe the zero point 0.7 or zero point 0.8 meters, depends. That's the pacing. What is a passometer? Passometer is instruments which should be carried vertically in the shirt pocket, or it may be tied leg or whatever. The mechanism of instrument gets operated by motion of the body and records the number of phases. Same thing it happens. It is counting instrumental way, mechanical way, and we are counting the number ourselves. That is the thing. And pedometer, this is also similar to the passometers. Okay, and the another type of measuring the horizontal distance, that's a odometer. It's an instrument which is attached to the wheel of the cycle, just your the speedometer. Okay, or other any vehicle. It records the number of revolution made by the wheel. Knowing the circumference of the wheel, the distance can be found. That is another one. Next one is the speedometer. Horizontal, sorry, the odometer may be calibrated to give the distance directly. If it is used for a particular vehicle, this is called a speedometer. All other what we are using the called speedometer in the vehicle, maybe the bike or it may be in the car. Speedometer generally we used to put it, and distance also we can easily measure it digital way. That is the best one. Okay, and tape measurements are used to measure the lines and offsets, and classified depends on the material used. Metallic tape, steel tape, okay, and cloth tape you can use it. Depends on what they have the resources. Okay, that is how the things. And okay, and that is a thing, right? There are some things called cloth or line tape. It's a 12 to 15 width, on it's a big one. And yeah, you have seen the tape, metallic tape, cloth, and even in a steel one. Okay, steel one, you have seen the many different tapes. Okay, right. And metallic tape, steel tape, you have that, you have seen that. And then invert tape, that is a little bit mechanism controlling the the things. Okay, sterilize. And okay, so these are all the different type of instruments which we can measure with that. The distance, horizontal distance, there is no angle, huh? Only measuring the horizontal distance, either by walking or by taking the tape, or by taking the metallic tape measurement, or it may be taking the odometer, speedometer, anything. That is only gives the horizontal distance of measurement. Okay, and the next part is that what are the accessories required. Keep it in mind, what are the accessories required for horizontal measurements. What are those accessories required for horizontal? One is arrow, second one is a pegs, third one is ranging rods, okay, and ranging poles required, offset rods required, nails required, wires required, pumping norm is required, and line ranger is required. Okay, these are all the different the instruments, the or you can call it as accessories required for horizontal measurement of. Okay, right. So here, let me go with the arrow. You need the arrow for horizontal measurement of the survey. So when the length of the line is to be measured, so more than chain length, it is needed to mark at the end of the chain length, and arrows are used to for this purpose. They are made up of 4 diameter and tempered with the steel wire, and its end is sharpened and it's bent to keep the loop. Okay, and the second one is the peg to mark the station point. Wherever the station points you create, you need to mark it with the wooden pegs, which are used to made up of hardwood of 25 size. Okay, and the next one is the ranging rods. Yes, of course you would require the ranging rods. For ranging rods, intermediate points in the measuring 2 to 3 meter long rods used. Okay, they are made of with a hardwood and are provided with an iron shoe. Okay, and these rods are usually circular in a section and 30 dia. Okay, and if the distance is if generally the distance is more, they used to provide with the 200 okay, because you need to, it should be visible in the very long distance also. Okay, and yeah, these are the the arrows. These are the arrows which you can which will identify that. Right, ranging poles are similar to the ranging rods, except they are very longer and 4 meter they are 4 meter to 8 meter long. Okay, and 60 to 100 meter 100 you know the diameter will be a very thin one. Okay, offset rods, these are all also similar to the ranging rods, 3 meter long one. Okay, can show you that some of this. Lace required, lace and wax. So to mark the Plates are 0.5 meter and 1 meter long sticks of softwood, and they are sharpened at the end. They provide to white line or light colors to mark the intermediate points. These are all for to mark the intermediate points. Okay, and this is actually white are pieces of sharpened thick sticks cut from the nearest one in the field. Okay, and one end stick is sharpened and other end is fixed. Okay, and plumb knob. This is the most important one. Plumb bob. Okay, this is actually the what is there in the plumb knob. In measuring horizontal distance along the sloping ground, plumb bobs are required to transfer the points to the ground. They are also called as a check the verticality of the ranging poles. Okay, line ranger. It's an optical instrument used for locating the point on a line, and it also consists of isoclase prisms. It's having the prisms placed one over the other and fixed in an instruments with a handheld. Okay, and these are all the things which you requires. So here you can see this. Here you can see the lines ranger line alignment for purpose. This is a plumb knob. Generally we use it for plane table surveying. I'll show you that plane table surveying where we are going to use this plane tables to make the centering of the plane tables. There are different types of the plumb knobs will be there, and here is the optical square, what you call this, ranging gauze. This is a line ranger, optical square of round shapes. Okay, and here is the tripod, and you need the ranging rods like this. Why we are putting the white and red? To visibility, is for a visibility of the for particular uh, the persons there, because maybe at 100-meter or 200-meter very far, it's very difficult to see the rods if there is a gray color. That's why we put the white and red color there. Okay, that's a typical one. And yes, this is a prisms, the optical prisms. Generally we use it for this prism for uh, total session surveying, right? Total session surveying unit we use this. Otherwise we will use the ranging rod only for dumpy level, auto level, and even for theodolite. Okay, and these are all the different ranging rods. Height will be the different. Some are maybe 3 meters, some are maybe the 4 meters. And yes, instruments you required for the ranging rods. So here you need the chain, you need the pins, that's called arrows. Pegs you required for intermediate points, and ranging rods required for the alignment where the distance measurement, and plumb bobs for total session, or and also for the plane table surveying. Okay, yes, chain, arrows, pegs, ranging rods, plumb bobs, hand levels. These are the the accessories you require for the survey part. Apart from your total session instruments, theodolite instruments, dumpy level, auto level. Okay, apart from those instruments, you need the accessories. These are all called accessories. Without these accessories, you cannot do the survey, right? So you need the chain, you need the arrows, you need the pegs, you need the ranging rods, plumb bobs, and levels. Okay, as I told you, this ranging, chaining, and offsetting, these are most important, and it's for a chain surveying. Instrument used for the chain surveying, it is chain, tape, arrows, pegs, ranging rods, offset rods, plumb knob, cross tabs, and hammers. Okay, crash straps generally we use it for alignment of the grid, where there is gridding for 10 meter by 10 meter or 5 meter by 5 meter gridding. There should be the 90-degree angle. That's why we use the crash tab. That's also made with a wooden bricks, right? Okay. So requirement of chain surveys. As I told you this, this is a requirement of chain surveyings. Okay, those things we discussed there. Yeah. This is all about the today's class, especially for the what you call different instruments, errors we discussed there. What are the accessories we use for the survey part, and these accessories are very useful. Without these accessories we can't do anything in the survey part. The instrument is very, very important. Along with this, accessories is also very important. Okay, these things you need to keep it in mind. Okay, and it's very, very important. And yeah, how to measure the horizontal distance. What are the different instruments? Pacing is the one method. Passometer, pedometer, and speedometer. And also with the tape. These are the different what you call this measuring methods of the things. Okay, and we discussed the what you call this classification of the what are the classification of maps are there. What are the different maps you can generate? Okay, let us have the small quiz on this today's session. Okay, right. It's a general questions. Anybody can answer for this. And the first question: who has prepared the uh, topographical maps? Who has prepared? Which organization has prepared the topographical maps? Anybody can answer this.
Survey of India.
Survey of India. Yes, that's right. And what are the features you can identify from the topo sheet?
Roads,
Yes,
mountains, rivers, dams, etc.
dams, etc.
Mm.
No, don't say etc. Okay, anybody can some other features. Okay, okay, no problem. Anybody?
Reservoirs,
Yes. Anybody? Other
I,
students can. Adikeshu.
Yeah,
Anybody can.
reserves, lakes,
Yeah. Mm-hmm.
like
That's it.
natural
Okay.
resources.
Chiranjeevi. Chiranjeevi.
Canals.
Yeah. Canals. Okay. Right. Right. Darshini.
Tunnel.
Tunnels. Yeah. That's right. Darshini. Okay. Dipti. Dipti. Divyasri.
Sir,
Yeah.
present, sir.
Dasharath. What is that?
Dasharath, sir.
Hunapa. Dasharath. Dasharath D. Why you joined 2 times there?
Sir, in
Dasharath
laptop
D.
I don't have mic, sir. For attendance, so I came through phone, sir.
Oh, is it? Okay, okay. Dhananjay Kumar.
Yes, sir.
Okay. What are the features you can identify other than this? Other than this, what are the features you can identify from the topo sheet? Okay. Where we are using this topo sheet? Harini? Divyasri? Where we are using this?
so when we like when we are used to construct dams and
Okay, okay.
like
Correct. That's right. Yeah, correct. Divyasri?
Sir, construction of tunnels, sir.
All
We
right.
require.
All right. Then, yes. Harshita? It, yeah.
For renewing the survey.
Yeah. What else? Hitesh Gowda. Hitesh Gowda. Madan Kumar. Madan Kumar.
Yes, sir.
No,
Yes, sir.
not for attendance. I'm asking the question.
It's a fit.
Okay. What are the different, the measurement, methods of survey? Horizontal method, horizontal distance measurement. What are the different methods? Manish? Just now in the last, at the end, we discuss. Manoj? Mohammed Sanif? No. Sharat?
Traditional
Sir,
Mhm.
chain
and
survey, tape
Yeah.
survey.
Correct.
traditional
Go ahead. Okay, what are the accessories are required for surveying? Renuka? Neha? Rohit? What are the accessories required for surveying? I'm asking the general surveying. What are the accessories required? Just now I told you. Rohit? Renuka?
Plumb bob.
Correct. Then? Okay, next Renuka? Neha? Okay, right. Okay, then okay. Generally, we use this for reservoir construction, tunnel, and town planning, military, and even for irrigation, reservoir construction, tunnel, town planning, mineral exploration, mining. Okay, almost all the sectors we use this. Okay, this is a very good map. The next part is that we use the accessories, they called maybe the arrows, and also for the the ranging rods, staff, and also for the prism. Okay, those are the accessories we generally use it for the survey part. Okay, and now we need to have the on the next sessions we used to go for the deeper level of that part. Okay, and what about the MOOC? Just now I shared in the last class the MOOC, introduction to the the GIS part. Have you started that?
No, sir, we should start it.
Started. Okay,
We are
still
not
today is
facing.
9th. Today is 9th. By 12th or 13th, if you submit that certificate, it would be a good. Okay, it's the easiest way. That's not a big one. Okay, that's the introduction part. You can easily learn it. Okay, that's the thing. Right. All right.